Everyone. Well, good morning for the people that is in the region of Peru and South America. Thank you, Babette, Tena, for the invitation, and it's a great opportunity for a mineralogist from Peru to show our work. Let me share my screen. Okay, just let me know if something wrong happens. Yeah, I proposed this title, The Ecology of benthic foraminifera across the shallowest OMC of Peru. But actually, I wanted to show something that I haven't shown in other presentations. So I began to explore some data that was published from international cruises that happened in my country, well, in the sea of my country. I'm gonna explain some particularities of this area. So I just want to begin. Thank you, my university that allows me to do my work, and all these institutions. IMARPE is the Peruvian Sea Institute that develops a lot of campaigns for oceanographical studies. The IRD from France, through the many projects that I've been part of, such as Paleotraces, and the University of Federal Fluminense from Rio de Janeiro in Brazil, where I get my degree. I thank the Cushman Foundation and the TMS for this opportunity again. So I want to begin by defining very quickly what an OMC is. OMC stands for Oxygen Minimum Zone. So many of you might know what OMC is, but just a broad definition is that it's an ocean area, a marine area with oxygen deficiency, and it generates about a combination of poor ventilation and high productivity. So physics and biology collides and generate waters with very pure oxygen conditions. So the one in the East Tropical Pacific is the largest one, and in one of the more intense in the in the global ocean. If we look at this panel, we can take a glance of the extension of the OMC of Peru. So Peru is between the 3 and 18 degrees south in the Pacific, in the East Pacific. So this volume of water is in front of Peru and the northern and central part of Chile. And it's a volume with very low oxygen levels, almost in the very core is anoxic, and it's subjected to the variability of some currents. In the surface and subsurface, there's the Peru-Chile undercurrent that feeds this area with very low oxygen. But this area is also very close to the equator, and the equator is subjected to the most climatic variability known nowadays, I think, the ENSO variability, this El Niño Southern Oscillation. So the Peruvian Sea is subjected to events like El Niño and La Niña. Another variability that is not very well studied yet is the one related to this deep current, the Chile-Peru deep countercurrent, that feeds the area with waters from the Antarctic intermediate waters. So that's very oxygenated waters, but with a low pH. So there are corrosive waters, and in some sense limits the lower part of the OMC. This is a closer look to the OMC of Peru to get the vertical extension of it. So around the 8 to 14 degrees of Peru, we have the broader vertical extension. It goes from 100 meters to 700 meters. So it's very shallow in comparison to other oxygen minimum zones in the globe, and it's very intense. The core, as I said, it could be very microxic or in some cases anoxic. The OMC is not static in time. It changes in the position, the extension, and the intensity. I want to show a couple of examples of it. Sorry. This is for the area of Pisco. Pisco is at 14 degrees south, also in Peru. This is the work of Salvatecci and collaborators in 2022. They used in a sediment core, so this is a paleo study, for the MIS-5E, and in a comparison to the Holocene sediments, they used the delta of the nitrogen-15, these stable isotopes of nitrogen, as a proxy of the water column denitrification. So the nitrification is a process that is very important inside the OMC. When there is no oxygen, the nitrate is used as an acceptor of electrons by the organisms. So when the denitrification is stronger, then the OMC is more intense. When the denitrification is weaker, that's because the OMC is less intense. So in the MIS-5E, they have this variability. It's very long through many thousands of years. And in the Holocene, you have another type of variability that's almost centennial variability with a lot of ups and downs. In closer times, in this panels in the right, we have this example of the intensity of the OMC, again with delta of nitrogen-15. For the last millennium, we have that it has ups and downs, and it's related to the exported productivity from the surface to the bottom. And this is indicated by the TOC, the total organic carbon concentration in the sediments. We did it also for the last centuries. Again, delta N15 has a variability, and in general, it presents a weakening of the intensity through the last decades. Why the paleo studies are important? Because we don't have measurements, obviously, of several parameters in the past, because we didn't have the instruments. And in Peru, we only have the instrumental data begins in 1960. And we only have the measurement of oxygen in our waters since this year, thanks by IMARPE and several international cruises. So in this last panel, we have a lot of many time series of oxygen in several trend to oxygenation. It's very slight, but it's present. In a closer variability, in a closer time scale variability, that it's interannual variability, we have this time series of Callao, that's 12 degrees south, where we are subjected, as I said earlier, to the ENSO variability, that is El Niño and La Niña events. We have in this panel the anomalies of temperature for the first 100 meters. And this line indicates the thermocline. In colors are the anomalies of temperature. So here we have the extreme El Nino in 1997, 1998. So, and we can see how the thermocline deepens accordingly to these oxygenation events. The opposite happens during La Nina, for example, in this year. And these temperature anomalies are associated to the oxygen anomalies here in this panel. For example, in this extreme El Nino, when the water became very warm, the oxygenation rised very strongly. So this is an extreme El Nino. And if that happens, the depth of the oxygen minimum zone is lower accordingly. So in this line, we can see how the OMC depth changes through time in accordance to this interannual variability. In the right panels, we have sections of the oxygen of Callao, that's 12 degrees, for a normal phase, so La Niña phase, actually. So we can have a strong, a very shallow upper limit of the OMC and a very extensive OMC developing in the first 500 meters. But when El Nino happens, and this is the extreme El Nino of 1997, you can see how the upper limit deepens down to 200 meters, and the core is shrinked. And apparently, the lower limit is affected as well. So apparently, there was also oxygenation happening in the bottoms. We couldn't see this because this is a model for only for the first 500 meters of depth. So on average, what happens to the sediments of Peru? This is a map of the oxygen limitation over the sediments of the upper continental margin. So in other words, this is the oxygen that are right a couple of meters over the sediments in the shelf and the upper margin. And you can see that from 9 degrees to the south of Peru, these sediments are covered by very microxic and anoxic waters. So this zone in central Peru is very good for studies of oxygen deficiency, and also for paleo studies, because we can have a very good preservation of sediments with a very nice lamination as well. So what microhabitats we have for the benthic organisms? So basically we can have 4 microhabitats, 4 that we have detected yet. Close to the coast, we have in the inner shelf, we have sediments with a very fluffy layer in the first centimeters, and a very intense sulfidic zone. There's a lot of productivity coming from the surface, and the waters are very anoxic, and in the sediments, the pore waters are sulfidic. In the outer shelf, we have a little more oxygen, but only traces of oxygen, and the sulfidic zone it deepens, and we can start to see organisms that live under postoxia. So that's between the anoxia with sulfite and the anoxia without sulfite. So these Theoploca sheets, for example, these large bacterial filamentous bacteria, they represent biological nitrate stocks for other organisms. In the upper margin, we begin to have dissolve nitrogen in the first millimeters of the sediment. So there is a nitrogenous zone, and the sulfidic zone is very deep in the sediments. And in the lower limit of the OMC and below the OMC, we begin to have some oxygen in the first millimeters of sediment, and the nitrogenous zone is more, you can see it very well now. And the sulfidic zone disappeared for the first centimeters. So foraminifera lives in in all these habitats, microhabitats, across the OMC, from the sulfidic zone to outside the OMC. So this is only some photographs to show how our sediments, or the sediments in this OMC look like. These are the Theoploca sheets. This is another surface sediment. And this is some example of sedimentary records. You can see that they have very pretty laminations. So the foraminifera that live in OMCs have some particularities. Cojo and Piña Ochoa made a very nice summary of these particularities. They did it for the Arabian Sea, OMC. So they define that there are different communities or a zonation of the species from the upper OMC through the core of the OMC to the lower OMC and below the OMC. So in summary, the foraminifera here are mostly hard-shelled, mainly calcareous and agglutinated. They have very high densities, but they are small in size. In a more recent work by Nico Glock and collaborators, this is from the last year, they have another summary here. So across the OMC, this is the depth of the water, this is the water depth. Across the OMC, the remineralization of organic matter goes from very high rates to lower rates across the OMC. It goes with the decrease of oxygen and a lightly increase to the lower limit. The nitrate increases across the OMC, and that led the foraminifera to grow larger. So across the OMC, you can see that foraminifera are very, very small in the core, but to the places that have very intense remineralization, like the upper limit of the OMC. But when you reach the lower part and below the OMC, you have larger foraminifera. So, and it is associated with the potential of the nitrification of this foraminifera in the upper limit. The nitrification is low, but because foraminifera is growing in size, this process or these rates increase with this increasing of size of the body. So the nitrification becomes intense to the lower part, from the core to the lower limit of the OMC, and below the OMC it begins to decrease again because there's no more oxygen limitation here. So thanks to the nitrification and other adaptations, foraminifera can thrive through these sediments that are very extreme. So here, I just want to show, after this introduction, a little long, to define changes of benthic foraminifera, community changes of benthic foraminifera across the OMC of Peru at an interannual scale. So this is a study that haven't been done yet. I want to show some first results that we are finding. I want to talk again about the ENSO variability, because it's very important if we talk about the interannual scale in Peru. For this matter, we don't use the Niño 3.4 region that is in the Central Pacific. We better use the Niño 1+2 region because it's closer to the areas, and it indicates more it indicates effects, more direct effects for our area. So then we have several indices developed for this area, Niño 1+2. I'm gonna use the ICEN, the ICEN, that is developed by IMARPE, and it goes from red, that is El Niño events, to or warm phase, to blue, that is La Niña events, that is the cold phase. The white is the neutral phase. In this panel, we have the dynamic height of C, that is an indirect proxy of ventilation of the area. And this lower panel, we have the chlorophyll A anomalies, that is that is used as a proxy of productivity of the area and exported production to the bottom. And these four lines, these four red lines, indicate the cruises, the international cruises that happen off Peru and retrieve foraminiferal data. Most of it is published. Some data is not published yet, but you can see it now in my presentation. So the first one in 1997, December 1997 and January 1998 is the Panorama Cruise, and the other three are meteor cruises from Germany, and they happen in November 2008, January 2013, and May 2017. So they happen in different phases of the ENSO variability. These are the cross sections of the oxygen from the coast to the ocean for these four cruises. For the Panorama cruise, we only have down to 500 meters. For the other ones, we have down to 1,200 meters. So for a better comparison, I'm gonna shrink it here. So in the Panorama cruise in 1997, we have, again, as I explained some minutes earlier, an extreme El Niño. So we have we got the chance to work with foraminifera from an extreme El Niño event that doesn't happen quite a lot. And for the other cruises, we have an oxygen minimum zone that is well developed with a strong core for 2008 and another strong core for 2013. And for 2017, there's a clear core of the OMC, but you can see that through time, this lower limit apparently gets a little shallower. So here we have apparently this deep current from the Antarctic area is getting stronger through time. We're gonna then explore what is happening to foraminifera in this place and also across to the OMC. So just very quickly, all these foraminifera samples were retrieved using a multi-core, again, from the coast, that's around 70 meters of depth, to the depths around 1,000. The deepest sample is 1,200 meters. So the design of this study is as follows. We have 4 sampling campaigns, the Panorama and the 3 meteor cruises. I divided the data in 4 bathymetric zones. That is the shelf from 0 to 200 meters, the OMC core from 201 meters to 500. The lower OMC from 501 meters to 700 meters, and below the OMC, that is 701 meters to 1200 meters. So in the following figures, you're gonna see a lot of colors. So the light blue is for the panorama, that is the 1997. The meteor 77, that is for the data, this is dark green, is for 2008. The M92 is for January 2013 and is in light green. And the last one is the Meteor 137 that happened in May of 2017. This is in red. The foraminiferal community attributes that are used for is the abundance, the agglutinated to calcareous ratio, and the Shannon index for the calcareous foraminifera only. The environmental parameters that I assessed or that I used are the TOC, total organic carbon in the sediments, the bottom water dissolved oxygen, and also I estimated the concentration of the carbonates in the bottom waters using some empirical models from this paper, Allen et al. In 2012. So first, with the density of foraminifera, I'm going to show only the figures with strong or with more interesting data, obviously. The density was expected to be correlated to an indicator of organic matter of food in the sediments. So the only indicator available was TOC. That's not the best indicator for food for foraminifera. We better have the labile organic carbon, but that was not available for all the samples, only for a small group. But as we wanted to see interannual differences between these sampling periods, the most interesting difference that we can see is that here in green, in light green, is the M92, that is 2013, versus all these dots in dark green that are from 2008. And they have very different abundances in general for all the section of samples. And this is discussed as it could happen because the sampling periods were developed after different periods of productivity. So in 2008, this is late 2008, it happened after a very low primary productivity period. Here in red is the sampling period, but here before it, we have a very low productivity period. And if we compare it to M92, January 2013, here in red, before that, we have the productivity rising through many months of the year. So in 2012, there was a very steep rising trend of productivity, and that could help to explain the differences in the standing stocks of foraminifera. So we have in this data the result of the months previous to the sampling period, right? Foraminifera live no longer than 2 months on average. That's from the studies that the low number of studies that have assessed this. There's no study yet of the time span of benthic foraminifera in an oxygen minimum zone, but it's hypothesized that it's no longer than 1 month, maybe. So the numbers of foraminifera are the expression of what happened in the previous month, maybe the previous 2 months in time. Here is a figure for the diversity, the Shannon index of calcareous foraminifera, and this is versus the logarithm of dissolved oxygen +1, because there were very low values. And we can see 2 groups. This group of the data from the shelf, the squares, and the OMC course is the circles. Here is very explicit group. The differences in time from this data are mainly because of the diversity of redox gradients in these sediments. Again, the oxygen is not a better tracer for this zone. This is a zone with very microxic to anoxic waters, so it's very low. And foraminifera are then responding to the variability of nitrate and sulfite, and also the food, right? And in the other part, we have these inverted triangles that are the deeper samples, the deepest samples. And we have a difference again between these green triangles from the M92 to the other triangles. And this might be a result again of the higher exported productivity to the bottom that happened in 2013. But again, this is not reflected in TOC, but in LOC. Only for these 2 sampling periods, we have values of labile organic matter. For 1997, we have a range. That means for these 2 light blue triangles, we have this range. And for these 3 triangles, we have this other range that is almost twice the values of 1997. So these are below the OMC, but the productivity might take a while to reach these depths. But again, it helps to understand the differences in these 2 foraminiferal communities in time. We have here the agglutinated to calcareous ratio versus the oxygen and versus the estimated carbonate concentration. We use this ratio as an indicator of the conditions of oxygenation and the saturation of calcite. So you can see in the shelf and the core of the OMC that we don't have a lot of agglutinates. There are agglutinated foraminifera across the OMC, but they are not very abundant. They begin to be very abundant from the lower limit to below the OMC because there's less calcite available in the waters. So calcareous foraminifera, these hard shell foraminifera, they are not very allowed to thrive better in these sediments. And the agglutinated takes this chance and dominates this realm in oxygenated waters. So you can see that when the oxygen is higher, then this ratio goes higher. They are pretty high values on these 2. This one is for the 1997 sample. So this and it goes again with a very low availability of carbonate in the waters. So again, it's not helpful for the calcareous foraminifera, but it's good for the agglutinated, and they tolerate this condition. And this point is only 1 point, but 1 sample give us the interpretation that maybe during this cruise in 1997 there was again another ventilation, but of the area, but was happening below the OMC. The other sample, there was another sample, have an N of 2, is here. So it's in this cloud of points, but it's not low as these other ones. So we have two samples that were very different, but this one is around 1,200 meters, and this one is around 800 meters. So this might explain this difference of the value. So maybe this needs more exploration. We have an indicator of ventilation during this period. A deep ventilation during the El Nino, the extreme El Nino event that wasn't indicated neither but by sampling or by modeling of the area. Very quickly, I want to show how the community zonation happens. This is for the M92 2013. Have up to 60 species and 5 assemblages. They change from the very close to the coast to very deep in the ocean. So again, from 70 meters to 1,025 meters here, the diversity of species increases with depth. In the shelf, we have up to 6 or 8 species, very low number assemblages, and very diversified assemblages here with agglutinated and calcareous foraminifera. You can see these small photographs here. And they respond to the redox in the pore waters. I have here in this left panel in red the sulfide concentration, in blues the nitrate concentration, and in yellow the oxygen concentration. As a manner of Trox model, I highlighted the abundances of these 8 species of foraminifera. I wanted to talk very quickly about only 2 of them. Bolivina seminuda, that is the queen of the OMCs, at least in this OMC is very abundant in the core and through the OMC down to this station that was, gonna see very quickly, 600 meters. And Bolivina spisa, that is not present across the OMC, only in the lower limit and below the OMC. So I work with these 2 species in the next figures, the final figures, because they are bolivinids, they are opportunistic genera. They live in the close to the sediment water interface. So there are other species that are very abundant or important in this area, but they have different microhabitat adaptations or preferences. So, for example, Villarina peregrina here, they have the same distribution of Bolivina spisa, but it presents these subsurface peaks. So I just choose Bolivina spisa because it lives right in the surface of the sediment. Just to go to the end of the presentation, I'm gonna talk very quickly about Bolivina seminuda, the abundances of percentage in relation to the oxygen. So I didn't expect a correlation between oxygen and Bolivina seminuda, but I wanted to see if there were some differences in time of the samples from the shelf and the core of the OMC. And in this picture, we have this group of samples that very low numbers of Bolivina seminuda. For this species that is very dominant, it's always from 50% to up to 90 something percent. These numbers are low and they happen in disoxic waters, but with very, very low exported productivity. So this might explain why Bolivina seminuda was not dominant in these sediments. This point is from the extreme El Nino event, the light blue, and these three are from the 2017. This was not El Nino, a classical El Nino, but it happened right after a coastal El Nino. A coastal El Nino doesn't have the same origin from the ENSO variability, so it's not very related to ventilation of the area. But it's very interesting that Bolivina seminuda respond similarly in two different conditions. And Bolivina spisa work with it with the oxygen and the concentration of carbonate. Again, this species is not present in the shelf and the OMC core. It begins only to thrive only in the lower limit to below the OMC. And have a lot of triangles for this species here then. And we have the highest numbers here in these triangles that come from these lower OMC samples from the two first campaigns, 1997 and 2008. And the other samples, the rest of the samples present low values. This is still in exploration because Bolivina spisa from studies of Nico Glock, they have using the porosity. It's a good indicator of changes of oxygenation, but the numbers of Bolivina spisa, the changes in time, might need to be studied in parallel as well as this with these other parameters as porosity and other morphological features maybe to understand and interpret these differences. But Bolivina spisa apparently is detecting some variability in these deep areas. I just want to conclude and thank you for your first. Thank you for your time. These general conclusions from this study is that using ecological features of benthic forams is still an adequate approach for assessing OMC variability in time, so it doesn't get old. Even though in time many proxies, modern proxies appear, like geochemical proxies based on the test of foraminifera, using the ecological features are still a good tool for environmental variability. Additional proxies need to be assessed with this data that I showed, like normalized weight, the porosity, test geochemistry as well. And apparently, we have detected a trend about that is associated with ventilation in the deepest waters of Peru. I want to thank my group, Forums, these young foraminerologists of Peru and Chile as well. We have friends in Chile that work with us. And I want to thank the biosciences team of my university that let me work and play with foraminifera. Muchas gracias to everyone. And thank you for your time. And sorry that it took a little longer, way longer. Sorry. I am open to questions.
Thank you, George, for the very interesting and informative presentation. And now it's open for discussion. And I can see few comments in the chat you want to read by yourself, and you want to answer that from Malcolm and from Robert. Or if you are there in the meeting, you can please unmute yourself and post your comments to George.
Yeah, sorry, the audio is not very good. Can you repeat, please?
There is a comment from Malcolm in the chat box. You want to
okay, in the chat.
Yeah.
Basically, the question is, he says, in fossil OMZs, I doubt many people would expect larger specimens. Indeed, smaller forms usually take as a guide to lowered O2. But then Robert suggested, oh yeah, but it was it not below the OMZ that the benthic foraminifera became larger, basically?
Yes, yes, yes. I just inside the OMC, mainly in the core, the foraminifera are small. At least in this OMC, in the upper limit, the specimens are even smaller. But in general, in the core of the OMC, you can expect, and you are going to find small foraminifera. It is that when you reach the lower limit and below the OMC, that you get the larger specimens. Larger specimens of species and larger species as well.
Thank you. So with this information, just follow up on this question, with this information, how would you be able to use it in the past to look at, these kind of things? Or is it kind of just only for modern times that it's kind of useful? How would you kind of apply it in the past?
Yeah, here, at least for Bolivina seminuda in Peru, we have detected, in other areas it happens as well. There are at least 2 morph species. In the upper limit of the OMC, we have very small seminudas that are heart-shaped. And in the core of the OMC, we have the classic form of Bolivina seminuda. That's the large one, like in the picture. And if we make a study of trying to correlate these changes in size with the environmental conditions, we maybe have maybe a ratio to use through a sediment core, but it depends on the species, right? If I use Bolivina seminuda, then I can compare conditions from the core versus from the shelf that are typically sulfidic sediments in Peru. So maybe there is a proxy. Great idea. Thank you, Babette, that we can detect this variability through time using this only in one species, the changes in size and in the shape of the forum.
Thank you.
And there is one more question from Dharma. Thank you very much for the lovely presentation of your results. A little question. Did you use the stained forams for the study or also unstained ones? If the second ones have been used, did you use a age control in the sediments? For example, from the forams, or you picked?
Yeah, all the data that I show is from stained specimens. So we interpret this as they are the living ones during the sampling, right? We didn't use we didn't use the unstained foraminifera. So as I said in the presentation, this data might represent what was happening in the last 1 or 2 months, maybe in time. So if you have the living ones, right? Because if you use the unstained, the dead specimens as well, then you have a larger period to assess. So in order to be strict with it, I read this data of these cruises, and they all used rose Bengal stained forams.
Thank you. There is one more comment from Rao. Nice presentation, George, regarding the oxygenation trend below the OMG. Have you explored any relationship with the southern annular mode? I'm thinking that the latitudinal gradient of the westerlies might affect the northward export of Antarctic intermediate waters.
That will be great to assess because, again, this presentation arose in the last weeks when I was invited, and I decided not to show something that I had presented before. So I began to explore this data of different cruises, and I don't know about the variability of the annular mode of the south. So it is a good question that comes. I'm happy that it looks like a very nice scientific questions to assess. I'm sorry that I don't have the answer now, but it's a good start point maybe.
And one more query from Rohan Subha. Thank you, wonderful for the wonderful presentation. Have you observed any change in the roundness of the disc and the spiral forms of the benthic forams?
Yeah, just this is a first phase of exploration of the data. Just now, I present data of working with the numbers of foraminifera, mainly diversity indices that derive from the numbers of the specimens of the species. But I don't have all the samples in my power, so I can't assess these morphological features yet, because the morphology of some species is interesting to assess in this type of variability. So I wasn't thinking on working with the spiral forms here in this OMC. Have a lot of Casidulinas, Nonionellas. You might be referring to those genera, maybe. Thank you for your question.
Yeah, there are no more questions. Thank you for addressing all these, George. I'll take a short moment to just share my screen.
A short comment from me?
There is no more comment. Thank you for addressing all these questions. I just want to give an introduction or just a brief out regarding the upcoming seminar next month, which was postponed from the February month. So we'll be having a talk of Helen Coxon, Atlantic foraminifera and the high Arctic past and present time period on 10th of April on 15 Central European time. So once again, thank you everyone for joining. And
yes, and thanks.
Seminar.
And thanks, Jorge, for